just as there are laws of exponents that relate to multiplying with the same base, we have laws related to dividing with the same base. And it does help to think about why these work the way they do. If I imagine having x cubed divided by x squared, if I think about writing that out, I have x times x times x divided by x times x. 3 x's multiplied in the numerator is the same as x cubed, and 2 x's divided in the denominator is the same as x squared. We know that we can reduce factors in a fraction, so x divided by x is equal to 1. Another x divided by x is equal to 1. So this is 1 times x, or just x. When we look at that, we can see where the division rule comes from. Notice 3 minus 2 equals 1, which is where we're at when we simplify this problem. To convince ourselves that it still makes sense, let's just try it with two numbers that are slightly different from each other. If I have x to the 5th over x cubed, so x to the 5th divided by x cubed, I'll have to write out 5 x's for the numerator, and I'll have to write out 3 for the denominator. Doing the same division or reducing of the fraction as before, I have a 1 3 times. And then that's being multiplied by x and another x. So that leaves us with x squared. Notice again, 5 minus 3 is 2, and this is exactly where the division rule comes from. So when we divide with the same base, the rule says that we can subtract the exponents. Applying that rule, this problem says that x to the 8th divided by x to the 3rd is x to the 8 minus 3, or x to the 5th. In our next problem, there are a few different choices about how you might proceed. I'm going to show you two options. So option 1 is a straight application of the rule. In option 1, we say, all right, there's an x in the top, but not an x in the bottom. So there's nothing for x to do. There's a y in the top, that's y to the negative 2nd, and that's got to subtract the power from the bottom, so that's y to the negative 2 minus 3. This would simplify to x cubed times y to the negative 5th, and just as we've done in previous lessons, we know that we cannot leave a negative exponent in our answer, so we're going to have x cubed divided by y to the 5th. So that's one way to get to your possible response. But there is another way, and that is instead of straight up using the subtraction, we can remember that a negative exponent means take the reciprocal. So this term belonged in the denominator. So we could actually start by rewriting this as x cubed divided by the y cubed that was already in the denominator, and the y squared that wanted to be in the denominator. Notice this actually takes us away from using the division property and instead brings us back to the multiplication property. Our numerator is still x cubed, but our denominator is now y cubed times y to the 2nd, or y to the 3 plus 2. Simplifying, we get x cubed divided by y to the 5th, which is the very same answer that we got doing the problem the other way. For the last problem in this section, we could use either option 1 or option 2. I'll stick with option 1 for right now because it most directly practices the subtraction rule. Although I'll tell you that from personal experience, I tend to use option 1 myself more often. So let's take a look at this problem. In the numerator, we have a 3, an x, and a y to the 4th. And in the denominator, we have a 12, an x, and a y to the negative 6th. Well, we know that 3 and 12 have a common factor of 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So that will leave a 4 in the denominator. There's two different ways you could think about this. Notice you have an x on the top and an x on the bottom. We could just use what we understand, which is that x divided by x is equal to 1, because anything divided by itself equals 1. If you really wanted to, when you thought off on the side with me here, you could say x divided by x equals x to the 1st divided by x. That means x to the 1 minus 1, which is x to the 0. And we know from previous lessons that anything to the power of 0 equals 1. So that's further support of the fact that when you have something divided by itself, it equals 1. So that leaves us only with a y to the 4th and a y to the negative 6th. If we use the division property, we're going to have y to the 4 minus a negative 6 is divided by a 4 because there's still this 4 in the denominator. Remember 4 minus a negative is going to be the same as 4 plus, so this is y to the 10th divided by 4. Next, we have the rule of raising a quotient to a power, and this is the exact same idea as raising a product to a power. It basically says that when you have a division problem inside parentheses, and that whole division problem is being raised to a power, you could instead raise the numerator and denominator to the powers separately. So when we look at the first example, we see x divided by y to the third power. Using the property, we can say that this is x cubed divided by y cubed. It makes sense if we think about it. X divided by y times itself 3 times is what it means to cube it. And notice x times x times x gives you that x cubed for the numerator, and y times y times y gives you the y cubed for the denominator. So the property is just a shorter way of doing what we could do by writing it out. X squared to the fourth x squared divided by 3 all to the fourth says I can first take the x squared and raise it to the fourth, and then take the 3 and raise it to the fourth. Well, this brings up rules from lesson 2. When I raise a power to a power, I know I need to multiply the powers. So this will be x to the 8th in the numerator, and then 3 to the 4th is just a number. So if 3 squared is 9, and 9 times 3 is 27, and 27 times 3 is 81, 3 to the 4th is 81. So we have x to the 8th divided by 81 as our answer to this problem. Now, the last one in this section, I strongly recommend you think about in 2 phases. The first phase is the negative exponent, and we know that that means take the reciprocal. I would do that before anything else. I would come back in for a second step and raise it to the 4th power. So let's take these 2 steps. First, we're going to take the reciprocal. So the problem will become z divided by x cubed y squared. This is now being raised to the 4th power because we've used up the negative exponent. Now we can use the quotient to a power rule, which says that we can first raise the numerator to the power and then raise the denominator to the power. Now, you could probably do that all at once, but I'm just showing my steps really clearly since this is an introduction. Notice we're now using the product to a power rule, which says when I have x cubed times y to the 2nd, and I want to raise the whole thing to the 4th, I can raise each of those pieces to the 4th power individually. So my final answer will be z to the 4th divided by, remember when we raise a power to a power, we multiply the powers. So we have x to the 12th and y to the 8th. All right, to finish off this section of notes, we have 2 problems with scientific notation, so you'll want your calculator. So when we have a division problem, just like with a multiplication problem, we can divide the numbers and then divide the powers of 10, because the powers of 10 behave basically like x to the 5th and x to the negative 2nd in the way that they interact. So taking your calculator and doing 9.1 divided by 1.8, you're going to get a long decimal, so we're going to have to approximate. So if we approximate, say, to the nearest thousandth, we have 0.549 times 10 to the power of, remember the top subtracts the bottom. So we have 5 minus a negative 2, or 0.549 times 10 to the, since this is really a plus, we have to the 7th. But remember, when our problem starts out in scientific notation, we typically answer in scientific notation. And this number is not actually in scientific notation because we need the decimal point to move 1 place. When this becomes a 5.9, notice we've made that number bigger. We have to make the power on the 10 smaller by the same amount to keep it in balance. So there's our answer in scientific notation. For our final problem, we're going to have one that we have to square. So you have some options. I would probably try to simplify inside first and then apply the square, but it can be done in the other way. and you'll get the same answer. If I start by taking 1.4 and dividing it by 2.1, I'm going to get 0.6 repeating, which is basically 2/3. I can see that that should happen because notice if I had 14/21, right, move this decimal point and the same amount on top and bottom, that would just be 2/3. It would actually be easier to work with the fraction in this problem than it is to work with the decimal. So I'm going to go ahead and do that. I've got 2/3 times 10 to the, notice 9 minus 5 is 4, and then that is being squared. So when I look at this problem, I have 4/9, because that's what happens when you square 2/3, and 4 times 2 is 8, so this is times 10 to the 8th. Now, scientific notation doesn't have fractions in it, so we do ultimately need to get to the decimal. So if I take 4 and divide it by 9, I'm going to get 0.4 repeating times 10 to the 8th. But again, that's not scientific notation. I don't have a number in front of the decimal. So if I move the number to be 4.4 repeating, that made my number a little bit bigger. I need to go a little bit smaller. In fact, 1 decimal place smaller. So I have 4.4 repeating times 10 to the 7th, and that's an exact answer because the repeating is accurate.